this is the second part of my non-mathematical introduction to quantum computing. And if you haven't checked out the first video, check it out, where I give sort of a Roth introduction, a really 10 minutes non-mathematical introduction to all the key features of quantum computing. And what I want to do in this video and in the follow-up videos is I want to dive and explore each of the different topics. And I might, again, see and find things that I didn't expect. So this is not really prepared at all. So bear with me as well, because we're learning this together. I'm just trying to kind of condense a bit my knowledge and sort of like help build intuition myself, and then help you guys also build intuition. So in this first session in the second session I wanted to focus on how do you really can manipulate the information that you have in one qubit, and then we'll explore multiple qubits, because I think this is going to be a bit more complicated to understand. So the first thing is that what you can see, what I realize is that you have two types of so you've got two types of information you can two ways you can operate with a qubit. On one side, and that's what I find people talk about this in using the word amplitude, and this is the you can see the height of the bar here, which kind of maps to the probability of in this case measuring zero. It's like 100%. So this is one thing you can do. You can mess with these probabilities, and the other thing you can do is you can mess with the color of the bar in this case, which is what people refer to as the phase. Now, the way you modify those things, they're both sort of circular. This means that you can there are certain operations that allow you to parameterize the like sort of how you shift this information, and that's why they're called rotations, like Rx, Ry, Rz, because they rotate in the sense that at some point you just go back to the original state, and then you can just keep turning around and around. So you can basically, for example, you can move your amplitude from 0 to 1 step by step, but at some point it will just go back to 0, right? So that's the idea, and that's what you do with those gates here. So I want to focus on the ones that are kind of greenish here, or turquoise, and first show you what happens when you use the X, the Y, and the Z gates. So those are specific cases. What I realize is that the rotation ones are the ones you can use to kind of fine tune what you want to do, how you want to shift that information, how you want to rotate that information. I'm going to probably use that word because it just fits in with the notation. So rotate information around, and it helps me understand that this is all cyclic. And so it's not that you can keep increasing numbers, and you always go back to the same place at some point. So the X, the Y, and the Z are just specific cases, but maybe it's a better way to understand. It's a better way to start with this. So what the X gate does is it just moves all your amplitude from 0 to 1. If you apply it again, it moves it from 1 to 0. Pay attention, the color of the bar doesn't change, so the phase doesn't change in this case. So we're only touching the amplitude with the X gate. So exactly, you're only touching the amplitude using the X gate. It's kind of like a knot, right? So this is what you do with the X gate. With the Y gate, though, you're touching both the amplitude and the phase. So when you apply a Y gate, you go from 0 to 1, but now your bar is pink, right? And you can note in here that your information has gone to the complex component of this. So just a note on this: the numbers used to represent amplitude and phase can be complex. Complex as in imaginary numbers in mathematics. That's the only thing. I mean, you don't really need to know much about it if you don't want to get deep into the design of super specific algorithms. At the end of the day, complex numbers is just the laziness of mathematicians to say, I want to operate with another dimension, but I don't want to go into vectors, right? So that's what basically a complex number is. So if you don't want to have the vector 1, 1, right? Like you can just say 1 plus I in that sense. I mean, I might be wrong probably, but the idea is that I component tells you there's another dimension, but you just don't want to go and get into vector land, and you want to stay into sort of one dimension or one dimension less, which helps you with the arithmetics, and that works as well. So, but you don't really need to know that. It's just so you know that those are complex numbers. Um, and so this is what it does. So it goes exactly. And I if I'm correct, so based on what I've been reading and what I've been doing, the pink colored phase, this is sort of a quarter of your rotation, right? Remember I said the phase is sort of circular, so if you get a pink one, you mean you're like a quarter way of your full cycle. Blue is sort of your zero, and then you're kind of this is like a quarter of it. Uh, Intuitively, I think. So that's what the Y gate does. And pay attention that all those gates, if you apply them twice, you just go back to your original state. That's an important property as well. And what the Z does, the Z is a special one because the Z, it only affects your phase. It doesn't touch the amplitude, but it only affects the phase of the amplitude that you have associated to the one value of your qubit. Remember that a qubit can be in a state 0 and a state 1, or in something kind of in between, like 20% 0, 80% 1. So this Z is going to flip the phase on that 1. So for example, if you apply an X gate, and now you have all the amplitude in 1, and now you apply a Z gate, then it's going to turn yellow. Yellow is kind of, in phase terms, half your cycle. So if you're in yellow, you can be sure that you've done kind of like half the cycle. What this means is that later on you can play, when you add more qubits, we'll probably see that, because then you can represent multiple states at the same time. And if some of them have the yellow phase or the negative phase, and some of them have the positive phase, you can tweak things so that they cancel out. And that's really, I think that's one of the things that shows you how to operate with the phase. So you can already see that you have these two types of information that you can manipulate: the amplitude and the phase. Some of the gates touch both of them, some of the gates touch just one of them. It's a bit tricky to get everything really right in terms of what one does, and then when you get more qubits, it gets tricky because they can influence each other. So you really have to spend some time experimenting with that, and I encourage you to experiment with that a lot. To kind of get an idea of how this information is flowing. And I think it's really important to do that without diving into geometrical and mathematical representations of qubits, because it basically helps you get a sort of an intuition from the ground up, and then you can see what the mathematics behind it are if you're really interested. But you don't need that. You need that. So you need to dive into the mathematics if what you want to do is you want to do some crazy algorithm optimizations and stuff like that. But that's the same thing with classical computing. If you want to go and optimize something, then you need to go and dive into all the mathematics about the and then find those kind of like tricks that allow you to find an optimization that is not obvious, or a way to implement something, right? So that it's kind of the same. If you don't want to get into that detail level, you don't really need to go through the mathematics. So that kind of helps you understand that. So we talked a little bit about the X, the Y, and the Z, and I'm going to close now by showing you what the R's, what the rotation ones do. And the trick here is what confused me a little in the beginning is that I thought that the rotation on the X, so the Rx, was a way that you could basically do the X gate step by step. So you could kind of like, say that X maybe equals a certain amount of times applying the Rx, but it's sort of that's not the right thing. So it's the Ry, the one that does a similar, that moves the information in a similar way than X, and the Rx is the one that moves the information in a similar way than the Y, and then the Z and the Z, those actually map to each other. So, for example, if I'm going to use the Ry, and then here you have, by default, there's like a pi divided by 2 parameter. As I said, this is circular, so the way you can parameterize those gates are with radians. I mean, and pi, so 0, 0, pi is like 180 degrees, twice pi is 360 degrees. but don't let yourself be fooled in the sense that the parameter being two times pi doesn't mean that you really have given the full circle on your phase or whatever you're doing, right? So, for example, what this is doing is if I do pi, right? So if I do 0, then it's 0, right? So that's nothing. That's good. If I do pi, what happens then? If I do pi, basically I have the same effect that I have with the Y gate. Okay, so I go with the X gate. Sorry, so I now have all my amplitude into 1. So everything between 0 and pi basically helps me, stay in between. If I say pi divided by 2, then I'll stay in between 50-50. So now if I check my measurement probabilities, I have 50% probabilities of measuring 1 or measuring zeros. And that's really that's what I wanted to show you, right? So with this parameter, you can play with this, and then if you do pi divided by 3, that's going to be a little bit more in the 0 and a bit less in the 1. So your measurement probabilities are like 75% 0, 25% 1. So this means if I now were to go and measure this, where's the measurement? Here. So if I now was supposed to measure that like 1,000 times, then 75% of the times I will see a 0 and 25% I will see a 1. So this is the most important. And pay attention that the things that I said, for example, if I now apply a Z gate to this, what happens is, you remember I said it flips the phase of the amplitude that belongs to the one component. So that's exactly what's happening. So those operations can really be used together to make up more complex logic. So, but in this case, we're just playing with this. Now, the thing with this rotation gates is that they go a little bit farther, and so if you go past pi and you say, for example, pi times 2, right? So this is 360 degrees. Now you're back at 0, but look that your phase has changed, and that's pretty important as well. So this means it actually takes 4 times pi to go back to 0 with your amplitude being blue, so your phase being blue, right? So that's kind of, it takes really 4 times. So if you stay in between 3 times pi, for example, then you're gonna then you're kind of staying at you're going back to 1, but you have the amplitude, the phase. I keep saying amplitude. The phase set to -1. I mean, you can go ahead and map those, but you see, right? So the cycle is 4 times pi. Then you're going back to your original state. So this is the of course you can do something like, I don't know, times 2.5, right? And so that takes you to so what am I doing? Pi. So I'm in pi here. If I say 3 times pi, then here, so exactly, so everything between 2 times pi and 3 times pi, it's again doing the same. So if I do 2.5 times pi, I'm kind of again in the middle, where I have 50% probabilities of 0 and 1, but now I have the phase, it's negative overall, and that's a really important, it's a really interesting thing to see. So play around with those, and then you will then you will see how do you manipulate information. Now, you don't really. So this is, you can kind of feel that this is extremely powerful, because you can kind of play with a lot of information. But the true power of this comes when we add more qubits. So stay tuned for the next video. I mean, this is I just showed the RY. We can play with the RX, which basically is the same concept. It's not the same concept, but it's so what does the RX? What does the RX do? So the RY, if you remember, it kind of stays in between, exactly. So the RX and the RY, as you can see, it rotates, and it kind of, what it does is it also touches your phase, but turns it negative, right? And so the Rx, what it does is a similar effect, but instead of negative, it turns it complex. So it turns it like pink. So you can see the relationship between Rx, Ry, and X and Y. So you're basically playing with the amplitudes and the phases, and in each case, you're only kind of playing with positive or negative phases, and in some other cases, you're playing with complex phases. Um, So, for example, let's start, as I said, let's start at 0, right? So if you start at 0, then you start at 0. That's good. If you do pi, then what you get? Then you get the same effect as using the Y gate, right? So it's the same pattern. If you see, it's the same pattern. So you go back. You're now your amplitude is in 1, but it's pink. And if you do twice pi, then you're back to 0. But now it's interesting. But now it's negative. That's interesting. Pretty crazy. It's pretty crazy. So if I do 4 times pi, I'm back at square 1. So okay, so the cycle is still the same cycle, but it does mess with a phase in a funny way. In the sense that if it's 2 pi, it's then 0 with a negative phase. So you see, that's how you get a 0 and with a negative with a negative phase, which you cannot get with the Z, for example, right? Because the Z always negates your 1. I mean, sure, you can do things like you can put your amplitude into 1, then apply a Z gate, so you kind of flip it, and then you apply another X gate, and that brings you here. So you see intuitively how you can move these things around, and then you see how your amplitudes and phases are changing. So I think that's kind of the overall takeaway of this video. I wanted to show you quickly if maybe applying the RZ gate, which is the same concept, you need it to be 1, otherwise it doesn't. So what it does is you can specify the angle, so 0, 0, nothing happens here. But if you now do pi, then it becomes it's the same effect as like the Z gate. So it's the same idea, right? If I do 4 times pi, probably that's also the full cycle. So exactly. So that's basically I'm back at 1. What you can see here, though, is that concept that I said, that it's really circular, right? And actually, you can see that the complex phases and negative phases, they are part of the same. It's actually how you're rotating the phase, right? So so we said 0, 0, right? If I apply pi divided by 2, so I'm kind of like staying, not going to the yellow phase, then I'm going to stay in the pink phase. So if I now go to pi, then I'm going to the yellow. So you can see, as I said, that when you have the pink phase, is kind of like it's kind of like halfway to your negative phase, so to say. So you're rotating those colors and those values in here. I don't know, maybe here I'm trying to push it too far by not going into sort of a geometrical representation. But if you imagine a circle, yeah, that's kind of how you're rotating. So I mean, that's the way this works. But both amplitude and phase, they have this kind of circular nature, and that's basically it. That's basically what you can do with a qubit. Some of those gates in here, right? S, T, they are basically the red ones. They're basically also portions of Z. So if you apply a Z, right, you go to negative phase. So if you apply, I think it is the S, you go to pink, and you apply another S, you go to yellow. So 2 S's is the same as 1 Z. And I think the T is half the S. So if you apply 1 T, you get into some kind of purple. So this is in between your blue and pink. And if you apply 2 T's, then you're at pink, so that's 1 S. And if you apply 4 T's, then you're back at Z. So that's how really those greens and yellows, this is basically what you're doing in here with these gates. So that's how you manipulate information in one qubit without mathematics. just keep in mind this concept of circularity. So both amplitude and phase have that nature that if you parameterize them with angles, at some point they go back to their original value. How we can use that to compute and to make computations, we'll see in the next videos in this playlist. So enjoy and browse the channel if you want to see other stuff which is a bit more advanced. And I mean, I'm jumping in and out different topics, so sometimes I kind of create voids in my knowledge as well, and I then come back to this kind of doing this kind of videos, which I think help me as well, and I hope that help you as well to understand better what's going on. And I think I haven't really kept it under 10 minutes, so I'm sorry, but I think it's been pretty illustrative. Thank you.